Hey there, Y10s. In this video, we're going through exercise 8C to do with addition rule. Just a small detail to change here. I realized this should have been 20 people. So change that to 20 people. Now, in this one, to do the addition rule, I can give you the rule for it, but also it's easiest to do with a diagram. So you need to at least have known how to do a Venn diagram and a two-way table. All right. So this case scenario here, we've got 20 people in the class that we're going to survey. How many people prefer apples and how many people prefer bananas, right? Now they're telling you if 6 people like bananas only, so remember this is banana. If it's only bananas, that means I don't want A in that region. Okay, I just want the bananas. No one that likes apples as well. Okay, so that region there, remember that's B intersection, not A, so not apples, right? And that tells us that's 6. Whereas the other region, it says 4 people like both apples and bananas. Well, this must be 4 because that is the region where both you like apples and you like bananas as well, right? So that tells me there's a total of 10 people who like bananas. So I can write here A intersection B, that's what this region is. That's 4, and then B intersection A dash would then be 6 because that's essentially what you're saying there. You're saying bananas only, but not apples. Okay, so it's 4 plus 6. That tells me a total of bananas is 10. And then the next region, they say 9 people like apples only. So if you only like apples, remember this is the region for apples, but you don't want the people who like bananas as well. It's only apples only. So that region there is known as apples and not bananas, which we now know is 9. So apple and not bananas, that's 9 there. Now what I want you to see here is once I add these two together, I want you to see this. Can you see that when I add 9, 4, and 6, I'm going to highlight the regions here. 9 plus 4 gives me all of A, right? And then when I add on 6 as well, what I've colored now, isn't that the region for A union B? Because that's what A union B means. A union B means take all of A and all of B and combine them together, right? So this is where the rule comes in. And if you look at the Carnot maps, you can actually realize that 4 plus 6 plus 9, if you add those top 3 corners there, that actually gives you A union B as well. And this is going to help you when you're solving problems. Sometimes you don't draw the Venn diagram, you use a two-way table, knowing that those 3 regions is what gives you the combination of A and B all together. Okay, now here's the rule. The rule is A union B is probability of A. Okay, because you're saying, what's the chance of A union B? Well, you need to know the probability of all of A. So this is all of A, right? And you're going to add on probability of B. So all of B. So I'm going to add all of B. And I want you to notice this. So I'm going to do B. But can you see how we're doing an overlap? B has 4 and 6. And A has 4 and 9, right? So A is made up of adding regions of 9 and 4. And B is made up of the regions of adding 6 and 4. But can you see if you add these two together, you're repeating that 4. So that's why part of the rule, they say you need a minus A intersection B because you're doubling up with the intersection. And hence why you can see in this region, there's both green and red. Actually, you can't see it now, but there's an overlap of the green and the red. Okay? So all in all, what I'm trying to teach you here is that what can you take away from this lesson or this part here is to realize that A union B is, you can look at it as a formula, probability of A plus probability of B minus the intersection because you're overlapping. Or if you got a two-way table, you understand that it's these 3 regions add up to give you A union B. Okay, so I'm going to draw an arrow. A union B. There you go. Okay. All right. So now that you got that, let's now, probably didn't matter if you had 20, but if you wanted to fill out the table, it's actually easier now. That's 10, that's 1, that's 7. There we go. All right, so let's answer some questions here. Let's do some examples. Example 1. Example 1 says, two events A and B are such that probability of A is 0.5, and then probability of B is 0.6, and A union B is 0.75. Okay, all right. So I'm not sure if I copied these questions wrong. This is a bit funny. You know why? Because I reckon that was meant to be intersection. I think that's a mistake there, because why am I asking for probability union B there? Well, one of them is the intersection. Let's look at the textbook example. What do they normally give? All right, so they're probably, maybe what I wanted to ask was A intersection B. So change this one. That's a mistake. And let's draw that as intersection. All right, so one, we can fill out the two-way table to help us solve the problem, or you can use the rule in itself. If we're now talking about PR, which is the probability, then the total probability should be 1. Okay, they need to all add up to 1. So now we're thinking of it as all probability. So probability of A intersection B, which is what we're trying to find. We know that A union B is 0.75, so that means this region plus this region plus this region need to equal to 0.75. We know that total probability of A is 0.5. So all of A, if you add all together, these two regions, it should give you 0.5. So that means this is 0.5 as well. The other one is all the probability of B is 0.6. So this is 0.6. So we know this is 0.4. All right. And then they say that the total probability of A union B is 0.75. So we don't know these three regions, but when you add them all together, it should give you 75. Now, that's going to be a bit tricky, so it's probably best to actually use the rule. So here we're going to use the rule probability of A union B. So in total, it's you adding all the probability of A plus all the probability of B, and then you minus the probability of A intersection B. That's the rule, right? The logic is you're removing the overlapping region. Here we do know the answers. We know this is 0.75. They all need to add up to 0.75. And we know that all the probability of A is 0.5. All the probability of B is 0.6. And we need to remove some amount to make it 0.75. Now let's calculate that. What's 0.5 plus 0.6? Well, that gives you 1.1. And this is 0.75 here. All right, so if you add these two regions, so 1.1 minus what, which let's call it x, 1.1 minus what will give you 0.75. Now, you can use a bit of logic, or you can use algebra here to solve it. Another way of thinking about it is, or you can use a calculator, but you can think of it as this is 110, this is 75, so 110 minus what will give you 75, right? And hopefully you figured out that's what, 25 plus 10, that's 35. So really, I know just looking at it, I can tell that x has to be 0.35, okay? But again, you can use algebra in this case here if you wanted to. You could say add x on both sides and then minus 0.75 on both sides. And these two cancel out. So x will then equal to 1.1 minus 0.75. And if you do that on your calculator, you should get 0.35. Okay. So I now know probability of A intersection B must be 0.35. And once you know that, once you know this region is 0.35, now you can answer all the other questions. So all these are the regions. Now we know 35 plus what will give you 60. Well, that's what, 25, so 0.25. Down here, this would be 0.25 as well to make 0.5. And then 0.25 add to what will give you 0.4. And we know that's 0.15. There you go. So now that we know that, we can answer the question. So we can say, well, what's probability not A intersect with B? So not A and intersect with B. Well, this is not A intersecting with B, which is this one. So therefore, it's 0.25. Okay, so I can answer the question, so that's 0.25. So you'll find that the cardinal maps will help you do a lot of the calculations. The rule helps you to sort of just do calculations along with the cardinal maps. And then the Venn diagram is usually good for visual aspect to understand what's happening there. Okay. All right. And let's do the last example on this on your part of your notes here. So for those who don't play cards, there are 52 cards in total. There are 4 suits, and that's not including any jokers. 4 suits are this. So clubs, diamonds, hearts, spades. That's what suits are. And there are 13 cards in total. So ace is like your 1, and you got your 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you got jack, queen, king. So if you add them all together, that's 10 plus 1, 2, 3. There are 3 cards, or 13 cards there. And then 13 times 4 gives you 52 playing cards in total. Okay, so here's your deck of cards there, just in case you don't normally play cards. So let's say the event, so they say let A be the event that the card is a club. So the card is a club. So what's a club? This is a club. All right, so let A be getting a club. And B be the event that you get a queen. So B is to get a queen, right? So what's B? B is to get a queen. So you got a queen of clubs, you got a queen of diamonds, you got a queen of hearts, and you got a queen of spades. All right, so those are the possibilities. Whereas just clubs only, well, to get clubs, you can get ace of clubs, 2 clubs, 3 clubs, 4 clubs, 5, 6, 7. I'm just going to color all of this. And you can also get this one too. There you go. So that's what we got there. Now let's answer the question. Find the number of A. Okay, so in set A, how many possible elements are there? Well, there are 13 because it's ace to king. So clubs, there are 13 possible elements or outcomes. And what about B? B has 4 because you can only have queen of hearts, queen of clubs, queen of diamonds, and queen of spades. And then number of A intersection B. So how many out of all these cards here where both set A, which is being a club, and it's a queen. So there's only 1 queen of clubs. So there's only 1 of them, okay, out of 52 cards. So now when I answer the question, B, probability of A, well, A was 13 out of your 52 cards, which is actually a quarter, which if you look at the diagram, it makes sense. That's 1 row out of the 4 rows. So it's 1/4. Then how many is not a club? Well, then obviously it's the other 3/4, isn't it? So it's 3/4, or another way of thinking about it is you can take 52 minus 13 out of 52. Or if you're savvy with your fractions, we know the total probability is 1. So 1 minus the probability of A. So 1 minus quarter gives you 3/4 as well. Okay, so there's a lot of ways to figure out the A complement there. Let's go with triple I now. So what's the probability of A intersection B? Well, we know there's only 1 card that is a queen and a club out of your 52 cards there. All right. And then what's this? Oh, okay, now we're doing union. All right. So you can use the rule or you can set up a cardinal maps if you want to, but I reckon the rule is pretty easy at this point. Probability of A union B is equal to probability of A plus probability of B, and then minus the probability of A intersection B, right? Well, we already got probability of A, which we said it was 1/4. And actually, probably keep it out of 52, actually. So it was 13 cards out of 52 cards. The reason why is because probably A intersection B was 1 out of 52. So if you keep the denominators the same, it's easy to work out. The one thing I haven't yet figured out was probability of B. But we already know there are 4 queens out of the 52 cards. So you would say it's 4 out of 52. So now when you work it out, you can add the fractions together because the denominators are all the same. It's all out of 52. So 13 plus 4, which is 17. 17 minus 1. That gives me 16 out of 52 cards there. So just in case you didn't know what I was doing 13 plus 4 minus 1. And that gives me 16 out of 52. And you can then simplify that. Okay, on your calculator, you can just type 16 divided by 52, and it should simplify the fraction. Or if you can find the highest common factor, and I think it is, for now, let's try 4. So 4 goes into 16 4 times. And how many 4s fit in 52? I believe that's 13. And 4 out of 13 sounds about right. All right, cool. So that's probability A union B. And then finally, find the probability that the card is a jack or, oh, that's a key word, or not a diamond. So what they're asking you to do is find the probability of you getting a jack union, not a diamond. Okay, so not a diamond, so dash. All right, well, first thing is you need to find, so because if we use the rule, it's probability of jack plus probability of not getting a diamond, and then minus the probability of getting a jack and not a diamond. Okay, now this one you'll need to figure out each individual probability first before you can actually find the answer. So probability of getting a jack, well, we know there's 4 jacks out of 52 cards, so that's 4 out of 52. Plus, now what's probability of not getting a diamond? Well, not getting a diamond is actually very similar to not getting a club, because diamonds, you got 13 of them there. So if you don't want those 13 cards, well, there's the other 3 quarters left over, isn't there? So that should be similar to what we had before. It's probably easier just to do it this way. Let's think about it. So getting diamonds, probability of getting a diamond is equal to 13 out of 52. But since we don't want diamonds, it's the leftover. So 52 take away 13 is what? That's, is that 39? I think it's 39. Let's, 52 take away 13. Yeah, 39. So that means you've got 39 out of 52 cards that are not diamonds. Yeah? And then minus, well, what's the chances of you getting a jack and not a diamond? Well, there are 4 jacks. So let's have a look again. There are 4 jacks here, and there's really only 1 jack of diamonds, and then there are 3 jacks that are not diamonds. So it's 3 out of your 52 cards. And then back to the same thing again. We're on to 4 plus 39 minus 3, all out of 52. And what's that? 4 minus 3 is 1. So really that's 40 out of 52. So then in total you get, you can simplify this. That's divided by 4. So you get 10 on 13. So divide 4, divide 4. There you go. That's your probability of getting a jack or not a diamond. You've got 10 out of 13 chances, or 40 possible cards out of the 52 cards. Okay, so that's how you would do that, and that's what this exercise is about. It's working with the addition rule. So this is the rule that you want to get familiar with.